All right, welcome everyone. I'm happy to be here. Happy to be the last session for today. We're going to talk about real-time data streaming with Azure Stream Analytics, which is a platform as a service in the Azure ecosystem. So if you're familiar with Azure, you will find a lot of things familiar. And if you're not, then this is a great opportunity for you to dive into this ecosystem and get familiar with tons of great services. So to start off, a little bit about myself. There's tons of text, you can ignore that. And if you're wondering what I'm doing in the picture, I'm throwing away bad code. That's the pose I'm doing here. But as I was told before, I am from Sweden originally, but I'm currently living in Washington, D.C. since a couple of years back. I work for a company called Excella. We're a tech firm in Washington, D.C. And I run the .NET DC user group as well during our monthly meetings. I'm really passionate about data science and machine learning, but especially the intersection between big data, machine learning, and software engineering, where I'm originally coming from. So, I realized that I'm the last talk tonight, or today, before we go into a movie session or a dinner, but there's a couple of reasons to stay awake still and listen to this talk. And as I said earlier, we will be looking at Azure Stream Analytics, but it's important to understand that it lives in a larger ecosystem of multiple services in the Azure cloud. We'll be talking about Azure Event Hubs, a Service Bus, Logic Apps, storage accounts, machine learning service, as well as Power BI. And to keep things interested, I have brought a Raspberry Pi all the way from the US here in the front. So I will try to spend a couple of minutes to introduce you all to the topic and the service, but also leave some minutes in the end to demonstrate real-time data streaming from an IoT device. Very simple use case, but at least shows off the service and how you can use it and what you can do with it. All right. So let's start off with some basics here and talk about what a real-time stream processing is. And for those in the room that are already familiar with the subject, this may be very basic, but it's important to set some expectations here as well. So we see real-time stream processing all around us in everyday life. Credit card fraud is one of those big things where our bank is going to block our credit cards if there are fraudulent activities. For example, I need to notify my bank that I'm in Lithuania to make sure that my transactions go through when I'm here. I'm personally from life science pharma industry from the beginning. My degree is in chemical engineering, so I worked a lot in factories in the beginning of my career. And we have tons of real-time data streaming live on site there as well to make sure such things such as pressure valves doesn't spike, and we turn off equipment before anything breaks. And there's a separation here between cloud stream analytics as well as on-premise or edge computing, which we can do the same things. And the cool thing with this service is that you can use it for both. One is called Azure Stream Analytics Edge, and the other one is Azure Stream Analytics in the cloud. But it's the same language, same functionalities, so if you do one, you can do the other. So when we're talking about a stream, what is it really? Well, of course, it's continuous, and it's a sequence of events in time that are small and that generally has a timestamp and a value. And the important distinction here is that they are small. In kilobyte size, they're not megabytes. We're not sending pictures or big videos. We're just sending small chunks of data. And generally, we have them in JSON format, especially in this service, although we can have it in comma-separated format or other formats as well. And just at, I think, MS Ignite in Orlando a few months ago, last month, Microsoft released a new feature as well, so you can write your own custom deserializers. So you can have your own proprietary format for your company and deserialize it to that format as well for your purpose. So to set things in perspective here, we keep talking about stream processing, but the opposite of stream processing is batch processing. And batch processing, I think, is something you're all very familiar with, of course. It's something like running a data query on monthly or weekly term. We're trying to do financial report. We're trying to do our quarterly things, those kind of things. And when we're doing batch processing, we're always working with large volumes. We're always working with entire data sets or tables. Our results can take everything from minutes to hours or even days. And we don't get insight quick enough. Stream processing, on the other hand, makes it much more lenient here. We work with small volumes of data, and instead of working with tables, we work with time windows. So we have a sequence of time windows, and each time window we aggregate and group the data for, and we get our analysis out of that. So what real-time stream processing allows us to do is get real-time insight on the fly, and not having to wait hours or months to make an actionable insight and decision that can benefit our company. So what technologies are out there to do this? Well, there are tons of them out there, tons. We're talking 20, 30, hundreds maybe of different tools and technologies you can use. But just to focus on the ones you can find in Azure, there's a couple I want to highlight. And these are only the ones in Azure. There's tons of other open source technologies as well that you should be aware of that may suit your business needs better. But we have something called, of course, Azure Insight with Spark Streaming. We have Apache Spark in Azure Databricks, which is a really cool product. You can, of course, use it on-premise, or you can use it in AWS if you want to. I think Azure Databricks is one of those up-and-coming services. It's already here, of course, but it's really cool and has all this built-in tooling in it. It's very expensive to use in Azure, first of all. So just be a bit aware of that if you're going to use it. You can easily have bills of $8 an hour to use it for the cheapest alternative. So it can be very expensive really quickly, but you get tons of functionality out of there. And of course, we also have Azure Insight with Storm. But if you focus on Azure Stream Analytics to the left here, which we're going to talk about today, we can see things here like ASQL. So ASQL stands for Azure Stream Analytics SQL. So the way we create our continuous query and our analytics is actually normal SQL with some temporal aspects and built-in functions that we'll look at in a bit. The cool thing with this, and especially for someone coming from a software engineering background like myself, is that you can extend the functionality with C# and JavaScript defined functions. So, for example, if you want to convert Celsius to Fahrenheit or the other way around, you can easily write a JavaScript function, you can call it inline in your job, and you get the result out. A new thing they also released a few months ago that we'll look more into detail is the possibility to load your custom machine learning models in C# or in other language as well. You get billed in streaming units. Streaming units. It's one of those very broad terms. What does a streaming unit mean? Well, a streaming unit, as much other things in Azure, is a combination of CPU, memory, and storage. So if your queries are very long, so for example, you have a very long time window, you will have a lot more data in memory, so that will be very expensive. If you have tons of events coming in at the same time, let's say millions of seconds, of course, that's going to be a lot of data to process and storage and those kind of things, and it's going to cost you more money. But the good thing here is that you can design this yourself. You can do a lot of optimization here to save money. And the cheapest this can become is 11 cents an hour. So 11 cents compared to $8 an hour is a lot better. So a very cost-effective solution. So the general anatomy of a stream analytics job looks as follows. Very simple. You have data coming in from multiple ingress, data coming out to multiple egress, and in between you have the continuous query that constantly checks and detects conditions on your data. And based on the conditions, we can trigger one or more egress that we will look at in a bit. And inline in the SQL, you can call your Azure Machine Learning Service or Azure Machine Learning Studio, which is the old one, to get to make predictions in real time. So, see if this one works here. There we go. So let's talk about ingress and egress a bit. So ingress, of course, are data sources. So where can we get data from? And this is some of the really cool stuff in this service. So the place we can get data from right now is something called Azure Blob Storage, which is an S3 bucket in AWS, SQL Server, an Event Hub, which is like a Kafka implementation, or an IoT Hub, which is more specialized for IoT data. There's a clear distinction here between the upper part and the lower part. The upper part is more for reference data or slow changing data. Data that you want to use to enrich the stream. While the lower part here, the IoT Hub and Event Hub, are the things that you want to do your streaming live more or less. So why would you like to have reference data? Why is it so important? Well, let's take an example here of a toll system in Washington, D.C. When I drive my car in D.C., there's tons of scanning things on the highway. It takes a picture of my license plate if I run at a red light or something like that. And what does it do with it? Well, the license plate doesn't do much, right? It's just a photo. So the stream itself can enrich that data by taking the plate number and then joining the plate number on a database to get my billing information. And my billing information is very slow changing, probably once or twice every 5 years or so. So that's a reference data. And using the reference data, we can then send me a bill for my speeding or for my red light. So very useful. When it comes to data egress, the options are just endless. there's some really cool options here. And usually with a smaller group, I play Jeopardy here, and I try to see how many knows all of these services here. If you're, even if you're an Azure expert, some of these may be unfamiliar to you, but I will just kind of highlight some of them. So we have Power BI up here in top left here, which is like Tableau, getting real-time data insights, or real-time dashboards actually. We have Azure Functions for serverless, SQL Server, Cosmos DB for just storing things in a non-relational way, storage counts, table storage, Event Hub again. This is not Outlook. This is actually a service bus. I only had one person get it right on the times I've given this talk, but it is a service bus instead, so messaging. And then finally we have Azure Data Lakes, so if you want to dump data. So this is very cool because you may want to have different paths for your data. You may want to store your data in a data lake or Cosmos DB for batch processing later, or to build your machine learning models in a later stage. But you may also want to react to your data directly using an Azure function. For example, if you want to block my credit card, if someone's doing fraudulent activities, we can trigger a serverless function to do that blocking and closing my card. So there's a different thing here you can use, and you can, depending on use case, you can get good use out of this as well. So let's talk about Temporal Windows. Temporal Windows is it's kind of like tables in stream processing. Temporal Windows is the way we group and aggregate data, and there's multiple ways of doing that. The ways that generally are available in Azure ML Analytics are tumbling window, hopping window, sliding window, and a session window. So let's look at some of them, not all. So tumbling window, and if we look at this, we have the green squares here are representing of events, while the blue bars are, of course, time windows, a time window. And then we have time on the x-axis here. Tumbling window is equal in size. So each window is equal, and it starts after each other, so it's sequential. So an event can only be part of one window, not two. So it's very simple and very useful in many scenarios. A hopping window, on the other hand, is also sequential, and it's also the same length, but is overlapping. So when we define it in SQL, we define both the length of the window, but we also define when it's going to hop. So maybe we want to aggregate points for, let's say we want to have the average temperature in this room for the last minute, right? So a window is 1 minute long, but we want data outputs every 5 seconds. So we say, let's hop every 5 seconds. And the good thing to remember here as well is that if we define long hops, we only get data in a very short amount of time. So we want to make sure we have a good interval of data here as well to get a smooth curve. Sliding window, on the other hand, is a different kind here. So it's also equal length, but it's very random. It's all over the place. And sliding window, the idea here is that if we don't have data, don't care. Don't aggregate data. Don't do anything. Just be quiet. So why is this important? Well, for example, we can have, we can do wind monitoring for a storm. So in the US, we have tons of storms on the East Coast, in Florida especially, and you may want to measure the wind strength on a specific place. But you don't care if the wind is really slow, like if it's not very high. So you have a threshold saying if the wind is more than 10 miles an hour, report, otherwise don't report. So in this case, we may just aggregate data once we're over a threshold and start doing this sliding window in time. So it's useful if you want to save some data. Of course, you save some cost on processing as well here. All right. So if we move on from that, let's take a look at Temporal Sequel. So Temporal Sequel is the way we write our queries. And if you're a SQL developer, or just know SQL in general, which I'm sure most of you do, it's very simple. Super simple, and of course this is a very simplified query, can be more advanced, but this is what it generally does. So the things to look at here is, first of all, select star into output from input. That always gets me. I always so used to saying select this column and this column and this data from a table, but here you start with selecting something into an output instead. And you're doing it from an input that you define. And here we can see as well an example of our grouping in a time window. So we're using a tumbling window, and again that's non-overlapping and it starts after each other. So we say that the tumbling window should be 1 minute long and then keep going. So what do we actually, how does it work with Egress here, right? Let's say we have a serverless function, an Azure function. And we want to send temperature and humidity to that function. Well, if we select temperature humidity from our input to our output, what the job is going to do is going to convert it to JSON, and it's going to post it on that API. So the payload to that serverless function is going to be just a normal object with two properties, temperature and humidity. And the same thing, if we're doing it to a service bus, it's going to create a message for us in a service bus and put it in the queue for us with that information, that data. So it's very versatile and very easy to use and quick to get up to running. And there's multiple other ways as well. For example, if we do a Power BI dashboard, we can actually integrate this directly to the job, and we can get a real-time dashboard. And if we select star from our stream into our Power BI dashboard, we get everything out there. And the schema is going to be inferred from the data coming out of the stream. So there are tons of built-in functions in Azure Stream Analytics. I'm not going to mention all of them, but some of the things I do want you to think of are some of these, for example. So especially the one to the top left, anomaly detection. So we don't need to write our own custom machine learning models to do some machine learning stuff as well. If, for example, you are streaming, just a stupid example, but let's say you're streaming Bitcoin prices for the current day, right? And you just want to detect if there's fluctuation, or it's a sudden drop in price or a sudden peak in price. You can use anomaly detection to do that in line with just one line of SQL and calling that function. And in the background, anomaly detection is using ML.NET, which is an open source library for machine learning in C# that Microsoft supports. There's also other functions to get the first element in a window, get the last element in a window, and so forth. So just know there's tons of built-in functions that make your life a lot easier than it needs to be. All right, so let's move on to real-time inference. So this is something that is quickly evolving as well in this service. I think it's very cool. The architecture of this implementation to make it scalable and work really well is still in its infancy, I think. There's tons of options out there, and I'm going to show you a couple that I think you should be aware of. So if you want to make real-time predictions on incoming data, the one that I think is out of the textbook right now is this. So data coming into an Azure Event Hub, so think of it as a Kafka messaging system, and the stream analyst job just pulling data from that message hub all the time. And we can integrate in line with Azure Machine Learning Studio. Okay? Azure Machine Learning Studio is like AWS SageMaker. It's just a cloud service for machine learning. There's tons of options out there. But this is the native approach in Microsoft. Don't do this. This is going to be bad. This service currently has classic on its name, which means it's obsolete and old, and you shouldn't touch it if you don't use it already. It's using proprietary data. It doesn't support TensorFlow, doesn't support open source libraries, it doesn't support GPUs. You get the point, right? Not very good, but that's the old school way of doing this. If you are more into your own open source cross-platform libraries, you could do something like this instead, where we can have an event hub with data coming in, and serverless function, so Azure function, or think of AWS as a Lambda function, being triggered on incoming data. We can make inline predictions on that. It scales up as much as we need to. In our example, we can embed that model. In this example, is ML.NET, which is Microsoft's open source solution. But you can easily replace this with PyTorch or scikit-learn or whatever library you want. You can have any language of your choosing as well in an Azure function. So C#.NET is definitely not the only option here. I prefer this solution right now, actually, because it's very versatile and it scales very easily, and you have some more ownership of certain things here. There are two options currently in preview that you can use. I have tried both of them, and they are fairly unstable, but I have high hopes for both of them. I think that's definitely the future. The first one is integration with Azure Machine Learning Service. And it's very confusing. It's Service, not Studio. Services is a new thing here in Azure, and it's getting a lot of attention, and rightfully so, I think. This one supports Jupyter Notebooks, TensorFlow, GPUs, tons of open source libraries. It's much more modern Microsoft. The things we're used to seeing the last few years there with community involvement. And we can train our own models here. We can have ML pipelines. We can have ML ops, if you're familiar with that term here as well. And we can then call these endpoints that are exposed in a Kubernetes cluster directly from our stream analyst job. So it makes it very easy to use. It's very robust and very versatile. but I think you should wait at least half a year to use this because it will take some time to mature. And the last and final one that I want to love, but I struggle with, is the integration with ML.NET straight from the job itself. So you can call a user-defined C# function, and that C# function can expose your ML.NET model, so machine learning in C#, straight from the job. It's super simple if you're a .NET developer like I am, but it's currently, I think, not thought through enough to be used. I think we have to give this probably at least half a year or so to mature. I actually was in a phone call with the Azure Stream Analytics team about a week ago or two, because this was just released, and I wanted to show you all this functionality, but it didn't work. So that wasn't very helpful, but I think they're working on it right now, so we should see this working in the future. So that should be cool. All right, so enough slides. Let's look at the Raspberry Pi here. So what I wanted to show you today, and just to make it more interactive as well and get you some value out of this, is streaming real-time data from a Raspberry Pi to Azure and then take some actions on the data. So the Raspberry Pi I have right now has a light sensor, temperature, humidity, sound level, and distance. So very basic stuff, but things just to measure the condition in this room. And the data is then set up to an event hub as an ingress. The Azure Stream Analytics job is listening to the ingress, the Kafka system here. It is doing real-time it's not doing real-time inference. It's getting reference data from a storage account here. So the Raspberry Pi is only sending its serial number. And the serial number is not very useful to know which one it is. So it's joining reference data to get Alex's Raspberry Pi, for example, so more enriching information. We're then streaming it to a Power BI dashboard in real time. We're putting a message in the service bus queue if someone has approached Raspberry Pi. So it's measuring the distance all the time, how far the closest object is from the Raspberry Pi. So if something is closer, it's going to trigger a service bus queue. A logic app is going to pick up that message, and it's going to send it to an email inbox. And you can think of it as a burglar alarm, right? If someone comes into your house, you want something to happen. So this is more or less a burglar alarm that is built, and it's easy to use. I used to use Trello before, instead of sending an email, to give me a call with a recorded message saying something, alarm, alarm, someone's in your house, you need to go home. But my wife hated it, because it always came from random numbers in Kazakhstan or sometimes in just various numbers, because Trello uses the cheapest way possible, so they will route numbers through some other place, but it's always very strange numbers and then someone yelling on the phone. So she didn't like that, so I couldn't do that anymore. So email is good enough. All right, so let's see if technology works with us and if we can show this. So the first thing to think of here is I wanted to show what I wrote to send to the cloud. I think we can zoom in a little bit maybe to get you a better view. Let's see, that's good. And then we'll zoom in. Right. So what I want to show you is most of the structure of the data. So it's super simple, it's just a Python script on the Raspberry Pi. It's reading those sensor data from the sensors, I guess, and using GroovePy to get the communication working. And it's sending it through a package up to Azure. But the data structure is as follows, right? We have device ID, which is a serial number. We have sensor readings, which is a property on a JSON object. And we have tons of properties here for different values. So we're sending it up as a JSON object. So how many here has worked with a JSON object in SQL? Anyone? Kind of, yeah. Is it tricky, usually? Kind of, yeah. At least for me, before I started using this, it was not very intuitive. It sounded very strange. But this service makes it really easy to use, and you can, just as you do in programming, you can go dot sensor readings, dot temperature, and you can get those values of that object. So it's very easy to use and pretty clean. So let's see if technology is working with us. We have started this stream already, so it's pushing things to the cloud. It's possible that we currently don't have any data, because if the internet stops, it won't stream, but then we'll use a local input instead, so that should be fine. But if we use cloud input here, I want to show you what a normal, let's say, query can look like. So if you start very simple here, and just do, let's see, something simple here, like select star into output from input. And if you kick off this job, we'll see if we have any data in the cloud here or not. And for those not familiar with this, we're using Visual Studio here, which is just a developer tool for Microsoft. You can also use Visual Studio Code if you like. There's extensions out there for this that makes it fully possible to use. And what happens when we start this job is that we get a small command prompt open up, and the job is slowly starting. And we'll see if we have enough internet to get it rolling. Otherwise, I use the local input instead so we can get some data here. All right, it started at least. Test connection. I think I go over to local input because oh, actually, wait, let's hold on a minute here. It's starting. Okay, good. Look at that, beautiful. So if we magnify this and look at this data, let's see, magnifier. Oh, great. If you look at this, what we can see here is that we're getting data in all the time. So look, so the data currently is pushed to the cloud, right, into the event hub, and we are actually jacking into the event hub in our IDE and pulling down the data locally to look at it. And you can see here that we get the device ID we're sending up, we're getting a property for sensor readings, we're getting properties for the time the event came in, partition ID, and those kind of things here. So we're having data live from the event hub, which is awesome. So very simple query, but let's make it a little bit more advanced, right? So let's do something else here. Oop, not what I wanted to do. Let's do this one instead. So let's make it a little bit more complex. So before we run this, let's think about what we're doing here. So what we're doing here is actually using the sensor readings.temperature here, right? So we know we have a property called sensor readings on the event. We can then do .temperature to get the temperature, and .humidity to get the humidity, and so forth. But in the beginning here, you see something strange. You see something said UDF / from Celsius to Fahrenheit, and then like calling a function. So this is us using a C# function that we have written ourselves to convert Fahrenheit or Celsius to Fahrenheit, which is very useful when I'm in the US and no one knows what Celsius is. And the way we define this, and sorry if I'm squinting, but this is far away. Is the script here? Okay, good, right there. So the way we define this is that we can define it in the backend here as a simple C# function. And for most people, this should be pretty intuitive, but we're taking in Celsius here as our input value, so a double Celsius, and we're just doing a simple math formula here to get back Fahrenheit again. So this is just a very simple example how you can extend your functionality with JavaScript or C# or something else to make custom conversions that may have been more difficult, I guess, to read in SQL. Or if you just want to make it more compartmentalized and make it more usable, this is a good way to do that as well. So if we stop the other job and start that, let's see if we get some data here. And what we'd expect here is that we would have both the temperature in Celsius, but we'd also have the temperature in Fahrenheit. So we have our job here, we can wait for it to run. And also do. So while that's starting, I just wanted to know that this is probably the easiest way to debug and start jobs like this. You can do the same thing in Azure in the cloud if you wanted to, and write your queries, but it takes a long time to start a job and stop a job in the cloud, and it's very error prone because you don't necessarily know what's going wrong. If you do it in IDE, it's much quicker, you get better feedback. You can also push it to the cloud, you can push it to version control like Git, you can put it into a CI/CD pipeline, all those things. So it's much better integrated, and you especially close those feedback loops that otherwise would be very long and tedious. About a year ago, so when I started doing this, I was doing most things in the cloud before we had a really good tooling here, and I was so annoyed because things broke, and if one query in the job breaks, everything breaks, and everything just stops working, and it just says failed. And failed is not very helpful, especially not if you're new to this domain here. And I'll switch to local, so I'll show you something here, because otherwise this internet's not going to work. Let's see. So the cool thing is, if you want to test it out, you can actually have a local input, which is a JSON file, and the JSON file we'll be able to use for testing. All right, so we have some data here, perfect. So if we go back to the magnifier here, Let's look at the data a bit. So, as expected here, we have Fahrenheit to the left, so 62.6 degrees. We have temperature 70 degrees, humidity and distance. So, using a simple C# function, we can convert the data, and using that aggregation and projection, we can get the data we need as well from this data. All right, so last thing I wanted to show you, if things cooperate here, is I wanted to show you how this can look like. I'm not sure if... may skip that. We're having some internet issues with connectivity here, but I wanted to show you Power BI dashboard of how the data flows out as well. How many here are aware of the fact that you can use real-time dashboards in Power BI? Okay, quite a few. Wow, awesome. So you can output the data straight in there if you wanted to, and let's see if I get any data here. Okay, good. So you can create easy dashboard like this, very simple, but it's super useful if you want to get an idea of the data you're doing. So we're currently looking at real-time data from the Raspberry Pi right now, 20 degrees in the room, a nice humidity as well, pretty dry. But you can see things as the distance, of course, the closest object, and those kind of things. So super simple, easy to use, and you can, of course, think of multiple use cases for this if you want to. So if you're interested in getting started with this, I highly recommend, let's see, here. There's a GitHub repo that contains all the information. And the GitHub repo is on my GitHub, and it has both examples of streaming Twitter data through Azure ML Analytics, but also streaming IoT data, and it shows you what you need to buy to get it done, the GroovePy package, how to set up the Python information, those kind of things as well. So if you're new to Raspberry Pis, which I was when I began, this is a great place just to get started and get familiar with the domain as well. So it's a good way to recommend as well. And if you're interested more in how to do real-time inference with C# or .NET, there's also another repo on my profile that shows you some examples of doing that. So definitely definitely check it out if you had the opportunity to do so. All right. With that, thank you very much for listening. Hope you have a great evening and the rest of the conference. Thank you.